Good day, friends. Today I am here with the video regarding the safety valve. This is your auxiliary boiler safety valve part 1. In this one, we will see what is the need of the safety valve, what is the purpose, and the different classifications, and the complete structural detail. The diagram also I am providing so that you guys can understand the internal construction of the safety valve, and then the accumulation test which is to be carried out on the safety valve. Or the other thing is that the materials of the different parts which is attached in the safety valve, that also I will discuss. Okay, so these things are there in this video. Now, safety valve purpose. If you see that safety valve is fitted basically on the steam drum to prevent the excessive steam which is generated in the boiler due to various conditions, and it is going to release it. So this is the main objective. It prevents the overpressurization of the boiler. Safety valve is set at a pressure not exceeding 3% of the approved boiler working pressure. Okay. So whatever is the boiler working pressure, just 3% extra. Okay. When boiler pressure exceeds the set limit value, the excessive steam is going to release through the waste steam pipe. The set pressure of the safety valve is adjusted by varying the spring tension. We have the spring which is attached. I will describe it with the diagram. Don't worry about it. And we are going to adjust it with the help of that. And at least two safety valves are provided or fitted on one boiler. They may both in the same valve chest. That is possible. But when the boiler is having attached with the superheater also, then it is having the separate safety valve, and it is going to shut off from the boiler if it is to be fitted with the own safety valve. Okay. Now we are going to discuss about the safety valve lift. Basically, when excessive steam is generated, the valve has to lift and release it. So the valve lift is designed in such a way that sufficient amount of steam is released and reduce the excessive pressure inside the boiler. Basically, when the pressure exceeding the spring tension, then it will force it up against the spring force, and then it is going to be released. So the rise of that is called the safety valve lift. We will have a discussion on this with the diagram part also later on. The valve disc has a lip also on the periphery to provide the additional lift. As per the design, this is also there. We will discuss it later on in the other videos. The additional lift counteracts the increase in the spring load due to the compression part of it. That also we are going to discuss. Depending upon the lift, the safety valves are classified as the high lift and improved high lift valves. So we will see now. Why do we need two safety valves? Basically, it's an extra precaution which is being provided. Suppose the one safety valve is not lifting or it is stuck, then another one will do that. The pressure will increase little bit more. So each safety valve is designed in such a way that even if the boiler is firing at full throttle, still the safety valve opens and releases the excessive pressure. Once the one safety valve is capable of releasing the pressure. If in case one of the safety valve flatters, then other valve will lift and the release of pressure, that we are saying. The difference between these two safety valves are approximately 0.5 bar. Other one is a little bit higher than that. Okay, so this is something which is the need of two safety valves. Classification of safety valve. These are some of the common type of safety valve. One is your ordinary type, then high lift safety valve, improved high lift safety valve, full lift safety valve, and full bore safety valve. So we will see in the coming videos the description of it one by one. So in this one, the classification is there. Ordinary type safety valve, some of the description, it is the winged valve, no waste steam piston is there, and no floating ring which is being provided. Lift is approximately D by 24. High lift safety valve, it is a winged valve. Waste steam piston is provided, no floating ring again, and the lift is D by 16. Improved high lift safety valve, wingless valve, waste steam piston is there, and floating ring, and lift is D by 12. Now in this slide, I am going to show you the complete internal structure of the safety valve in a cross-sectional view. It is a very good description. So you can see that this is the easing gear which is going to be connected. Okay, the easing gear arm which is internally connected over hexagonal head enables the valve to be turned on the seat. This is the part. This is the hood which is basically gear. Loose fitting key which can be padlocked. Okay, so and this is your compression screw which is their compression ring, neck bush which is there. This is your neck bush, spring retaining cover. This is your valve spindle. This is the spring which you can see here. Okay, and this is a bottom spring cover serve as a waste steam piston. This is your the bottom part of the spring retaining cover which is acting as a waste steam piston. Also the loose rings serve as a cylinder for waste steam piston, you can see over here. Okay, and this is the small drain which is being provided here. One the quarter pin is also there in the spindle part, and the valve seat is secured by the set screw. Okay, so this is the thing, and this is your valve. So this diagram gives you a clear understanding of the safety valve. Okay, now this is the description. You can see here the part description, major parts. This is your spring part is there. This is your easing gear which is manually utilized when we have to release it and check that the things are working. Valve spindle is there, valve disc and holder which is there, you can see here. This is your valve seat which is being provided, valve body and the drain from where the excessive steam will be released, and this is your lift stopper which is being provided. So individual parts I'm going to show you in this coming part. Here you can see this is the device. The spring tension actually determines, this is the spring and tension determines the setting of safety valve. The spring tension is varied by adjusting the hollow bolt provided. This is your adjusting bolt which we have to tighten. We can tighten from here, and this is your adjusting nut which we can, after that we can lock it. And this is upper retaining block, this is the lower retaining block, this is the spring. Okay, so this is the adjusting, the check nut is provided for holding the adjusting bolt in place. The spring is made of the spring steel. The spring steel is utilized to make it. Okay, this is your lift stopper we have seen earlier in the main diagram. It is screwed on the valve body. It stops the valve lift at a predetermined position, and this allows the stabilizing of blow off. Okay, so it is set, and it is going to basically stop the lift, and it is allowing the predetermined lift. A set bolt retaining the lift stopper position. The lift stopper is made up of stainless steel. Material is stainless steel. Now we can see the valve body and the drain. This is your valve body. So blow down ring it is called, and this is your throttle valve. This is your drain part of it. So these are the screw which is being provided. The valve body house, the valve disc, spring, and the valve spindle. We have seen in the main diagram. Back pressure throttle valve is provided for minor closing pressure adjustment. The back pressure throttle valve. This is the part of it. A blow down adjusting ring is screwed on the lower side of the body, which can be adjusted for appropriate lift and prompt closing of the valve. Means after releasing of excessive pressure, it should close promptly also. That is also being ensured. The adjusting ring can be turned through a hole provided in the valve body. So that is also done over here. A drain valve is provided at the bottom of the valve body. The valve body is made up of cast steel. The valve body is of cast steel. That this is the drain valve which is being provided. Now we are going to see the easing lever. Easing lever, as you can see, this is the easing lever. This is the lock pin with which it is attached with the safety valve. So the easing lever is provided so that the pressure of the boiler can be reduced by blowing off the valve manually at the lesser pressure than the set pressure, because at the set pressure the valve will lift automatically, and due to the maintenance also, time to time we have to ease the gear and see that the valve is operating correctly or not. The fitting of the manual easing lever is a requirement of a national standard at insurance companies. That is also correct. When the lever is pushed up, it moves the nut and set on the threaded portion of the valve spindle. And what happens after this compresses the spring upward, so that the valve can blow off. So once it is being done in that manner, so what will happen, the spring will be lifted off and the manual blow off of the safety valve is carried out as a routine safety check and maintenance to prevent seizure, because it is not operated a day-to-day basis. Whenever the excessive pressure generated due to sudden mistake or some automation failure, then only the this safety valve works. Otherwise, the manual operation of this has to be carried out as the maintenance part of it and make sure that the valve does not seize. The lever is made up of cast iron. Here we are going to see the valve spindle. Okay, this is your valve spindle, and here the lifting nut is being fitted over here. The piston type of the valve disc rests on this valve seat, and the popping groove on the valve disc provide an extra lift. Okay, so the extra lift is being provided. The extra lift helps to counteract the increase in spring load part of it, and the spring is compressed by the valve lifting. So we know that this is the procedure. The valve is lifted with the steam pressure, and this is basically pressing or compressing the steam, and then only the valve will be open and lift and open, and then the steam will be released. The valve holder is fitted on top of the valve disc. This acts as a guide for the valve disc, and the valve disc and the holder is made up of austenitic stainless steel to prevent the erosion and corrosion part of it. Okay. Here we are talking about the valve disc and holder, which we have just discussed. The piston type valve disc rests on the valve seat, correct. The popping groove on the valve disc provides an extra lift, that is also correct. This extra lift helps to counteract the increase in spring load. Okay, so basically this extra lift provided, and it compresses the spring more. Okay, the spring is compressed by the valve lifting and the valve holder for fitting on top of the valve disc. Okay, so the valve holder is fitted on top of the valve disc part. This valve holder is acted as the guide of the valve disc, so it gives the guide. In main diagram we have seen that part. The valve disc and the holder is made up of austenitic steel to prevent erosion and corrosion, so that also is. Here the valve seat part. This valve seat is screwed on the valve body. Okay, as you can see the threaded structure. The seating surface is flat and smooth to ensure the proper sealing of it. Okay, the valve disc is pressed on top of the seat by spring. Keep pressed by the spring. Okay, and the valve seat is made up of again the austenitic stainless steel part of it. Okay. Accumulation test of safety valve. Now we are going to discuss the boiler safety valve accumulation test. So first of all, what is the purpose? Why it is done? That we have to understand. So the boiler safety valve must be subjected to the accumulation of pressure test, basically to ensure that valves are of correct discharge capacity of the boiler. So even if for the some of the regions, like automation failure or something, some happens, the boiler is firing with the full capacity, and the safety valve is being lifted up, so it must ensure that there should not be any damage and it discharge all the steam even if the boiler is firing with the full capacity. That is the main concept of it. So the difference, also one of the thing that sometimes it is asked, what is the difference between the safety valve and the relief valve? So that also I am going to tell you that this is the accumulation test will tell you all the story. So the difference between the true safety valve and the relief valve is that the safety valve will have the capacity to prevent the unsafe rise of the internal pressure of the boiler, even if the boiler is in full firing position or full operation. with full capacity. But this is not the story with the relief valve. This is one of the major difference. So now we will see how to conduct the test. So for conducting the test, we have to shut all the feed inlets and the steam outlets to and from the boiler. So we have to close it, and everything must be closed, and firing rate is to be maximum as per the boiler capacity. That has to be done. So we have already discussed down the each and every part of the safety valve with the diagram. Now we are going to see about the accumulation test of the safety valve. So we have to see, we have already discussed and we have seen the safety valve is fitted on the boiler's steam drum. Then we have to see the accumulation test. What actually this test is? Accumulation tests are carried out on the safety valve during installation of the boiler, and this test basically what we have to do, the steam valve, we have steam stop valve we have to shut, okay, and then we have to fire the boiler fully with full blow. We have to fire the boiler, and then we have to see the safety valve should be able to maintain the accumulation of pressure within 10% of the working pressure. Means the safety valve lift also and release the steam pressure. So then in that case, in any circumstances, the with any load, the pressure should not exceed more than 10% of the normal working pressure. So the safety valve should be able to keep it within that range. So that test is called accumulation tests. Okay. The smoke tube boiler are tested for 15 minutes. The 15 minutes. And water tube boiler are tested for 7 minutes. So this is the time duration. But generally what happened, the accumulation test is waived for water tube boilers. Maybe because this the rate of rise of the boiler pressure in case of boiler water tube boilers are higher than the smoke tube as that one, but it is chances are there that it would damage the superheater parts also. So waiving of this test is done for the water tube boilers, but for the smoke tube boilers done duration is 15 minutes. Okay. In such cases, calculation and previous experience of the actual capacity of the safety valves are taken into consideration. So when it is being waived off, these consideration must be there so that in future, suppose something like this happens, so then it will be able to capable of handling this situation. Okay. Okay, so I'm winding with this. In this video, I have discussed about the safety valve purpose, the need of it, then lift part of it, and then the classification, and after that, the diagrammatic representation is there, and each and every part, the internal structure and all the materials utilized for these parts, okay, for the construction of it. So an accumulation test is also being described in this video. In other coming videos, I will be coming with more descriptive explanation of the various types of the safety valve and the other boiler related operations, and also keep watching my videos. This will going to help you out in the exam part of it. Thank you.